Okay, so thanks to the organizers for the invitation to give this presentation. I'll give a brief overview of the HEPData project, including some new features. Then I'll explain how it is used to host pyhf JSON files. So HEPData is the open access repository for high-level data directly associated with experimental particle physics papers. These are typically the numbers corresponding to the data points either plotted or tabulated in the publications. Data from more than 10,000 publications are now stored in HEPData. So HEPData is a fair data repository, meaning that it aspires to make data findable, accessible, interoperable, and reusable. HEPData is complementary to other information providers in the field, such as the INSPIRE literature database or the compilation of particle properties provided by the Particle Data Group. Access to event-level data, particularly from the LHC, is provided by the CERN Open Data Project, and files of any kind, especially data or software, can be deposited with the Zenodo repository. So HEPData is funded by the UK government in the form of an agency called SDFC, and it's historically been based at Durham University in the northeast of England for around half a century. So obviously the data has been migrated multiple times as databases and computing technology have evolved over the decades. The last big transition was around 8 years ago when we migrated the data to a new website at hepdata.net that is now hosted at CERN. So this was a partnership with the CERN Scientific Information Service, who provided a software engineer to write all the HEPData software behind the new website. Details of the technology involved in this migration are described in a comments paper submitted to the archive in 2017. Although CERN now provide the computing resources to host HEPData, Durham University still provides staff for user support and software development. So I was hired in 2013 to replace the previous manager, Mike Wally, who worked on HEPData for more than 30 years. Durham University provided some software engineering support by Alison Clark for almost 3 years until she left the university last year, and Jordan Barres has now taken over from Alison. So around the time of the software development, there was also a transition in the way that data gets into HEPData. So historically, all the data entry was done by HEPData staff separately for each publication. The data was either extracted from tables of numbers given in the papers or submitted by the experiments by email. But the data was never provided in a standard format, so the HEPData staff had to manipulate the data before it could be entered into the database, which was very time-consuming and difficult to automate. Over the last 10 years, we've introduced and documented a standard data format and opened up an online submission system to give the experiments complete control over uploading their own data. So this slide summarizes the workflow of the data submission by the experimental collaborations. Submissions are managed by coordinators within each experiment or within each physics group who assign uploaders and reviewers. The review process can be carried out online, and several iterations might be needed before the submission passes review. The coordinator then makes the record public on behalf of the collaboration. Publication information is pulled directly from INSPIRE, and this can be done either at the start of the process or right at the end. So it's possible to complete the upload and review steps even before the corresponding publication is publicly available. So using INSPIRE, I can make a search for ALICE and CMS physics papers that have been published in a journal, then restrict to results that also have a HEPData entry. So these plots show that fraction for different years from 2010 until this year. The vertical line marks the transition to the new HEPData site in 2017. The overall fraction is 58% for ATLAS and 52% for CMS. But it's encouraging to see the fraction for CMS increase to 90% last year and 84% this year. There's a Jupyter notebook on GitHub that makes these plots, and I've also added a link to run it using Binder. These plots show the number of finished submissions in orange and the number of submissions in progress in blue for each of the ATLAS and CMS physics analysis groups. For ATLAS, the three most active groups are Exotics, SUSY, and Standard Model, while for CMS, it's Heavy Iron Physics, Higgs, and again Standard Model. But the number of submissions varies quite a lot between groups. This is a similar plot for non-LHC experiments. I've had to change the vertical axis to a log scale because of the large number of submissions, around 200 from the Star and Phoenix collaborations at RIC. I've linked to an interesting article published last week from Brookhaven National Laboratory that explains how Christine Natras from the University of Tennessee in Knoxville has recruited undergraduate students to reformat Phoenix data in the HEPData format. This is what a typical HEPData record looks like. So there's some publication information in the left panel. The middle panel gives a list of tables, and the right panel shows one of the data panel tables, including some associated metadata like a description and some keywords. A visualization of the data points is generated automatically. That's shown in the bottom right. And the generated plot can be compared to the publication plot shown in the top right. So we assign digital object identifiers, DOIs, for the whole record and each table, and also for different versions of a record if it's later revised. One major advantage of having data available in HEPData is that you can export it to different formats. You can choose to download either a single data table or all tables in one of 5 different output formats. So the native data format used in HEPData is a text format defined using YAML. A submission comprises a file called submission.yaml that contains metadata, multiple data tables, each in separate YAML files, and possibly optional resource files in any format. There are various output formats available, specifically JSON and CSV text formats, a YODA format for inclusion in a Rivet analysis, and a binary root file. So the Rivet developers have defined a new format, YODA 2, that improves on the original YODA format. So a couple of weeks ago, I modified the HEPData web interface so that the YODA option now gives the new YODA 2 format, while the original format is still available under the YODA 1 option. So thanks to Chris Guchu for providing conversion code to go from YAML to YODA 2. So HEPData was designed to have machine-readable metadata. We now embed schema.org metadata in HEPData web pages in the JSON LD format, and this is indexed by Google. We implemented content negotiation so that if you use the curl command on a record URL, it will return the JSON LD metadata instead of the normal HTML page. All HEPData search and record pages have a JSON equivalent that can be accessed with a URL argument format equals JSON. An example application is the search for all Atlas records and retrieve the access count field for each record to see how many times that page has been viewed. So I wrote a Jupyter notebook last month to get this information after a request from Atlas, and that's linked on the slide in GitHub or Binder. The format argument can also be used to download the data in different formats, and specific versions or tables can be obtained by adding further URL arguments. There's an option light equals true to reduce the size of the JSON by removing information on data tables if you're only interested in metadata on the whole record. And more documentation can be obtained from hepdata.net/formats. So going a step further, instead of using the HEPData URLs directly in your code, you can interact with HEPData from the command line or via a Python API. So a tool called HEPData CLI was created by Giuseppe De Laurentiis 3 years ago as a summer project. So it can be installed in a Python virtual environment with pip install. The first example here uses the find command to get the Inspire IDs of HEPData records from Bell 2. There's currently 4 records. The second example fetches the table names from a particular record. The third example downloads all tables in a CSV format. And finally, the last example shows you that you can even upload to HEPData from the command line if you have the right credentials. This slide shows an extract from a submission.yaml file, which gives the metadata for a table. So the metadata in this example are the table name, the location in the publication, a description, some keywords, and the name of the YAML data file. The additional resources allow extra files of any type to be attached to a data table. And the use case here is to display the original figure from the publication. The YAML format is defined by a JSON schema file that names the allowed properties, specifies which ones are required or optional, the type of each property, the maximum length of strings, and so on. There's a separate YAML data file for the table itself, which consists of independent variables, that's the bins, and dependent variables, the measurement itself. So each measurement value can have any number of labeled uncertainties, which can be either symmetric or asymmetric. As well as the column headers, you can specify qualifiers that appear at the top of the table. The right-hand side of the slide shows how the YAML input for the table would be rendered in a web browser. Again, the format of the YAML data file is defined by JSON schema. There's some more detailed documentation of the submission format on our Read the Docs site. YAML is like our programming language, so it's quite fussy about syntax, such as indentation and spacing. Unless the submission is small, it's recommended not to write the YAML by hand, but to use something like a Python script. And there are a couple of examples in the documentation. Data structures in Python map quite easily onto similar data structures in YAML. So I mentioned the JSON schema that define the format, and there's validation code that runs during the upload procedure. This validation code can also be run offline, and it's recommended that you do that to check your submission before uploading. Anyone who prepares a HEPData submission realizes that each one needs to be done separately, but there are some operations that are repeated between different papers. And so it makes sense to write a library with functions that perform these operations. Clemens Lang and Andreas Albert from CMS have written a Python library called HEPData that can read in text or root files and write the HEPData YAML format. So I agreed to move this library to the HEPData organization on GitHub to encourage wider use outside CMS. The latest release adds support for converting histograms from a scikit-HEP hist package. So that was just released a few weeks ago. Christian Holm Christensen wrote his own Python package that does similar things to HEPData. And my impression is that many experiments end up developing their own internal tools and documentation to help with HEPData submission. So Rivet is a framework widely used by Monte Carlo event generators for reproducing the final state with the associated kinematic cuts of an experimental analysis. So there's some Rivet analysis code associated with each publication, and HEPData exports data in the YODA format for inclusion in these Rivet analyses. You can search for records that have these Rivet analyses with a query analysis Rivet. A badge appears in the search results that links to the corresponding Rivet webpage for the analysis. The screenshot shows that there are 922 HEPData records that have an associated Rivet analysis. We've developed a semi-automated way to make links to analysis code. So the Rivet developers provide a JSON file that maps Inspire IDs to a Rivet analysis names. We run a task each night that reads the JSON file and adds new analysis to the database. We try to make this mechanism easily extendable to other analysis frameworks. So the authors of these frameworks would just need to provide a JSON file and specify the links to be made. So a few months ago, Jack Araz asked me to make similar links from HEPData records to MadAnalysis 5 analyses. He provided a JSON file mapping Inspire IDs to Dataverse DOIs, and I made the necessary modifications to the HEPData code. So now you can search for analysis MadAnalysis to find 26 records with a badge that links to the Dataverse landing page for the analysis code. A year ago, there was a workshop in Durham, and John Butterworth made a suggestion for a new feature to allow bidirectional linking. The technical implementation was done by Jordan Byers, and this feature is now deployed, but it hasn't yet been used as far as I know. The idea is that you can add a new field to the submission.yaml file with a list of table DOIs related to the current table. Then the HEPData software would render links in both directions. Applications might include linking theoretical predictions or covariance matrices to their related measurements. Similar bidirectional linking is possible between two related records. And the HEPData lib package has been modified to support these new fields, and I've linked to the relevant sections of the documentation. The title of this slide also links to the relevant submission documentation. So although HEPData records are mostly for tabular data, it's also possible to upload additional resource files of any kind. This is an example from an Atlas record, which shows some attached SLHA files, a C++ file, and an archive file containing full likelihoods in the HistFactory JSON format used by pyhf. We now assign separate DOIs for these resource files, which direct to a landing page, so the resource files can be cited independently of the whole HEPData record. We plan to do more to make these files findable, for example, by including the description in the search index. For the case of the pyhf likelihood data, we attach a special badge saying HistFactory, and it's possible to find these records in searches with a query analysis HistFactory, which returns 28 Atlas publications so far. There was a proposal for several years that HEPData should support submissions with pyhf JSON files, replacing the usual YAML data tables to enable a visualization of the likelihood data within the HEPData record. So work was started by Sinclair Perez from New York University in 2020, and he completed the first step of modifying the validation code to use a remote JSON schema for the pyhf JSON files. This work unfortunately stalled after Sinclair left his position, and the idea was later abandoned as being too complicated to be workable. Instead, I proposed that it would be simpler to write a standalone web application that could import resource files from HEPData and visualize the pyhf JSON data. So I'm pleased to see from the presentations yesterday that not one, but two web applications have now been developed, namely HF Explorer by Abe Megahead and Workspace Explorer by Volker Ostrup. So one limitation of both of the visualization web applications that was mentioned yesterday is that currently they can only import JSON files, but most of the current HEPData submissions have the pyhf JSON files inside an archive of some type. And this makes sense if there are hundreds of pyhf JSON files associated with a HEPData record. You don't really want to attach these individually. So I think the web apps need to be extended to import archive files as well as individual JSON files. If that's done and the web app could import all of the 28 existing HEPData submissions, we could consider adding a button to the HEPData record that would open the visualization web app and load the relevant pyhf resource file. Better guidelines for submitters by the experiments or by the pyhf developers could reduce the variation in the different formats. For example, recommending tar.gz instead of the other archive formats. We currently identify a HistFactory resource file if there's one of 4 trigger words in the description, namely HistFactory, pyhf, likelihoods, or workspaces. But to avoid relying on the description, an explicit type of HistFactory can also be specified in the submission.yaml file. So more details are available in the submission documentation or the HEPData lib documentation. So to summarize, HEPData is the repository for publication-related higher geophysics data, although it should be mentioned that it was designed for fast interactive visualization and on-the-fly conversion of data into different formats. So this means the data size must be kept fairly small, so at most megabytes, but not gigabytes, and the data should predominantly be in a tabular format. A command line interface has been developed to allow search, download from, and upload to HEPData. New features include the new Yoda 2 export and allowing the possibility of bidirectional linking between tables or records. We now have enhanced linking to both Rivet and MadAnalysis 5 analyses. pyhf JSON likelihood data is hosted as additional resource files. There's potential to add a visualize button for HistFactory files that would open a visualization web app and load the pyhf JSON, but support would first need to be added to unpack archive files. The HEPData code is all open source on GitHub and external contributions are welcome. In case of future questions, you can always email me at info@hepdata.net, or I've set up a public forum at hepdataforum.cern.ch where users can ask questions. Thank you.
Thanks very much, Graeme. That was great. So let's first go to Zoom to see if there's any questions there, because we have time for 1 or 2. Okay, so I don't see any hands raised yet on Zoom, so we can go to the room. Yeah, Karsten?
Hi, Graeme. Yeah, thanks for the nice summary. This is a bit of a maybe tangent question, but as you might know, we are, for example, developing this new JSON standard, the HS3 one, where we of course want to do something very similar as the pyhf JSON. And my main question is, since for the HS3 format, we intend to also have a specific metadata section. So what would be the relevant keys that we should for sure include in the metadata section of such a likelihood definition, such that it becomes as easy as possible for a page like HEPData to make use of it?
Right. So I'll go back to my slide. Yeah, so HEPData, the two main types of file, there's a submission.yaml file, and that's quite general. So that has metadata just that are fairly general, like the description, some keywords, and there's nothing, the actual data itself is in this file, data.free.yaml, and that's the actual data points. So I think if you're proposing a new data format, I think the submission.yaml would be mostly the same, and the specific data itself would be, well, in your JSON file rather than a YAML file. But if you're looking for metadata fields, I mean, I would sort of just use what we already have in submission.yaml.
Okay, so basically you're saying that we should just add whatever is in submission.yaml and add that to our metadata section.
Yeah.
Yep, thanks a lot.
I mean, given that the HS3 format is going to is going to be basically something that will be uploaded there, you could also imagine, you know, also just including the information for like the DOI for the entire like HEPData record as well. So.
One tricky thing is, you know, the reason we're uploading tarballs is because for most of what we published in Exotics and Suzy for Atlas, we have not just one workspace, but like 60 to 100 of them. So we're gonna have to do the same thing if we do that in HS3. It's not gonna be uploading a single JSON file. You're gonna be uploading a tarball, and HEPData is not gonna look at what's inside of it. So if you want HEPData to put any information on the website, you always have to put it in a YAML file. I think that's always gonna be the way that Graeme expects things to go. I don't think it could be possible that you add some explicit dependency on HS3 in the future, but I think it seems like the way moving forward is going to be to sort of separate dependencies.
Yeah, I think that's a good point. I mean, if you are just treating it like pyhf, then I guess, I mean, at the bottom, you would just load it as an additional resource. So in that case, there's only really a description that you need, and we could maybe introduce a custom type. But yeah, if you were putting it in a tarball, we wouldn't process that at all. So you could just choose what metadata you want to put inside that.
Okay, yeah, makes sense. Thanks a lot. Yeah, I mean, I think so. Jordan, maybe related to this point of having multiple workspaces. Yeah, I guess this is one of the cases where one could argue whether it would not make sense to put them all in one file, which is something that HS3 can do. But I think we can take this offline and discuss this in a further session at some point. Thanks.
Yeah.
Okay, so we have another question on Zoom from Sabina. So please go ahead.
Yeah, thank you. It's maybe more like a comment to the the discussion was just going on. I mean, I understand the motivation for uploading a tarball with the HistFactory likelihood and the patch sets, everything lumped together because it's easier. But to my mind, it would be really useful to be able to have direct linking, for example, with to have a distinction between the background only JSON file and the patch sets. And the patch sets can, I mean, with this bidirectional linking, it's now available that these signal patch sets could be directly linked to the respective results plot that are relevant for them. I mean, that they correspond to. So this would contain much more information. And
Yeah,
also to
I mean,
be directly pull a specific background only file from HEPData would be useful for tools who interface to the records. I mean, this is not for immediate. I mean, this is certainly a longer development, but I think it would be useful.
yeah, I mean, when we did discuss this native support, we were talking about how to organize the JSON files, and there was some proposal to define something called a palette, which would be the combination of the background only workspace and the patch set JSON files. I mean, maybe the pyhf developers could comment on, are you actually using a palette, or is that just an idea that was forgotten about?
So
I mean, the primary
think-
statistical model is a bit different from the patch sets, no? I mean, also in its reuse.
So to answer Graham's question specifically, technically what we've kind of been uploading are forms of what I originally defined as a palette. But I mean, because the palette is basically just an archive of the background only and the patch files. So the concept of a palette was a bit loose, so it could probably stand to be more formalized.
Yeah, one tricky thing that we found, at least from Atlas, is that there are cases where people upload a patch set and that corresponds to multiple different background files. And they also have, a background file with one patch set, or they have multiple patch sets for the same background file. And it's sort of that kind of relationship, meaning that there wasn't a guaranteed one-to-one mapping on some level, which is kind of why, at least for Atlas, we always put a README to describe how these files are organized. And that was just to figure out what everybody tends to do typically. And the hope was that we converge on something uniform, but it's been all over the place, so it's been hard to kind of unify it a little bit. I think maybe for what Sabine wants could be that we provide a way to extract a single file from a tarball that's currently on HEPData. That should be possible without having to unzip the entire tarball. But maybe the better option is to kind of discourage tarballs in the first place and force every JSON file, whether that's background only or patch set, to be added as a separate additional resource.
Yeah, but then couldn't they be hundreds of files for one HEPData record?
Yeah. So, I don't want to cut this off because this is obviously a good discussion, but I also want to be kind of cognizant of time. So I think maybe we can try and I think there's definitely some interest in having a birds of a feather session on this kind of topic at the developer section of the workshop. So hopefully we can try and follow up on this. Graeme, before we thank you and let you switch talks, HEPData also has this, like, I forget if it's called like playground or sandbox or something, right? Which allows
Sandbox.
you to, yeah. And so I realize that what I'm about to say might already be well implemented by many experiments, but maybe we should, in the experiments, be thinking about trying to build continuous integration and deployment pipelines that would be testing to sandbox. So then with kind of stand-in files instead of the real thing, so that we could then make sure that there's a nice way for us to be deploying in kind of a reproducible manner in the future. But yeah.